Hey everyone, welcome to the Forever Young podcast, where we meet with anti-aging, longevity, and regen industry experts to unlock the secrets of staying forever young. This podcast is sponsored by Harper Media. If you're interested in our solutions to grow and scale your business and stand out strong against your competitors, comment growth in the comments or visit our website at theharpermedia.com. Now, let's start the show. I'm here today with Scotch McClure, the innovative CEO and co-founder of Maxwell Biosciences, a company pioneering biomimetic therapeutics to combat infectious diseases and aging. We'll explore how his engineering expertise and over 20 years of leadership are driving breakthroughs in longevity and health optimization. Scotch, welcome to the show.
Thanks, Hayden. Great to be here.
And thank you for being here. So let's start with aging. Can you tell us what causes aging and what accelerates it?
Yeah, well, it's pretty well studied. Just because it's well studied doesn't mean that we fully understand. There's a lot of work being done in this field. From my perspective, I would say it's essentially what you would guess, right? It's the battle between entropy and order. And as we encounter damage, the body is trying to repair that damage. And as long as you're getting enough sleep, you're getting the right kinds of nutrients and water and all of that, you would think that you wouldn't age, right? But unfortunately or fortunately, we are born with a microbiome inside of us. And so it's not just the human cells that require nutrients and hydration and sunlight and all of that. The microbiome needs a lot of management, and the microbiome can get out of hand, as we know, right? Infections can occur. And so your body produces a peptide called LL37, like LL Cool J, or let's say LL Cool J when he was 37 years old. So that's how you can kind of remember it, right? The other name for that is human cathelicidin antimicrobial peptide. And that has become sort of my favorite peptide. And I use all kinds of peptides, lots of different biohacking and stuff. But LL37, it's a peptide that you can actually buy on biohacker websites and stuff. It is a peptide that is naturally, endogenously produced by the body. And you produce it in greater amounts when you get plenty of vitamin D, plenty of sunlight, exercise, and the right nutrition. In fact, it's also called a heat shock protein, which it's actually produced at higher amounts. For instance, like in a sauna, which correlates to longer life and better health span, like in the Nordic countries where everybody has a sauna, right? There's been a lot of study done there on that. So back to your question, like what is aging and what causes it? Well, LL37 is a key homeostasis peptide, and I believe it is the linchpin in human aging, or one of the linchpins in human aging. So the key there is aging is essentially the redefinition of homeostasis, where you would say, what is normal for a 70-year-old versus what is normal for a 20-year-old? Well, that is the definition of homeostasis for that individual at that age, right? And so what we're saying is that in our culture, we believe that homeostasis at 70 years old means you trip more often, your bones are brittle, you have wrinkles and maybe gray hair or maybe thinning hair or whatever, right? So, but you wouldn't expect that in a 20-year-old, right? And in fact, if you saw that in a 20-year-old, you would maybe rush them to the doctor or like, get them to a specialist or something. And you say, there's something wrong with this person because they have signs of premature aging, right? There's something wrong with them, right? So if you take those two people to the doctor at the same time with identical symptoms, right? One is 70 years old and the other one is 20 years old. One will be treated as a medical problem and the other one will be sent home simply because of their birth date. That is the only difference between the two. They could have the same name, right? They could live in the same town. And so what is it we're talking about? One person, right? We're saying chronologically, it's okay that they show these symptoms of degradation in biological function versus the other one. It's not okay. And we believe that we can reverse that in the other person. And we can't right? So, for instance, like in AIDS patients, and I bring this up a lot, in an AIDS patient, you could look at a 20-year-old man or 20-year-old boy, really, at that age, right? Um, uh, and you'll see all of those signs: sarcopenia, frailty, like wrinkles. All of the signs of aging are there in an AIDS patient. And in fact, there's many other disease pathologies that mimic the signs of aging perfectly, and those diseases are almost uniformly infectious. So when I started looking at that, and I thought, well, isn't that weird that we don't think about the microbiome at all? Most of the gerontologists within this field, so gerontology is the study of aging, right? And there's a field of specialist gerontologists who their job is to deal with old people all the time, right? And so when the 70-year-old goes into the doctor to talk to the doctor, they go talk to a gerontologist. Versus the 20-year-old goes in and talks to like a general practitioner, an internist, or whatever. Because the gerontologist is essentially trained to deal with a different definition of homeostasis. So it's normal for you to have all of these otherwise signs of a disease, but because you're 70 years old, we're going to say that's normal, and we're going to say that we don't need to treat you for those things. We're going to treat you for a bruise or something, but we're not going to treat you for forgetfulness, or your hair is falling out, or you can't walk right anymore, or like all of those things, really major losses of function. So I believe, and what the data shows, especially in the AI algorithms that we're using at Maxwell Biosciences, is that these degradations in function are fairly simply reversible. And it comes from a different series of different innovations, but the major one is a redefinition of homeostasis back to that 20-year-old definition of homeostasis. And then in order to redefine homeostasis, you have got to use the chemicals and the defining physical characteristics, peptides essentially, that define homeostasis biologically for the body. And the key homeostasis peptide that I have been able to find so far is this LL37, which unfortunately was named human cathelicidin antimicrobial peptide, which is just half of what it does. And the antimicrobial nature of the peptide, it's effective against all microbes, by the way. It's effective against all viruses. And so it's sort of a wonder drug when it comes to keeping the body clean and antiseptic, right? But it's also highly effective and is used mainly for apoptotic cells, apoptosis, which is replacing aged cells. So basically making sure that the majority of your body stays young, forever young, right? So if you were producing enough of this peptide all the time, you would definitely have an anti-aging effect, no doubt. Sugar depletes it. So sugar will actually deplete the amount of peptide that you're producing, because you have to endogenously produce it all the time. All of your tissues produce it. It's not centrally produced like by the thymus or something and distributed through the body. It's produced locally all throughout the body. So I found that really interesting. And then the other piece that I found quite interesting about this peptide is that it is also stem cell recruitment. It's key to stem cell recruitment. So everybody knows about stem cells and about how they keep you young, right? So it's both triggering the replacement of the old cell and also attracting the stem cells to that local area. And so that's involved in all wound repair, like the lymphatic fluid that comes out when you're a kid, you skin your knee, right? And when I skinned my knee, especially the first few times that I skinned my knee, I sat down on the ground and I looked at it, right? Because I'm like, wow, there's a lot of pain coming from my knee right now. And so, like, your focus goes to that place and you see the little bubbles of lymphatic fluid coming out, right? And you're like, whoa, what is that? Right? And you see that it's kind of sticky and it's yellow and you can see it's forming a scab or something. That is just chock full of LL37. It is just full, full, full. Like it's like mostly LL37. And that is what's causing that stickiness is LL37 has a high electrostatic component to it. And that the stickiness that you feel on your fingers is literally a static cling that is happening. And that static cling is what is causing the clotting to happen there. And it provides like a lattice, like a matrices for the stem cells to come up into. It actually gives it a direction, right? Like a graph paper, right? It's like a matrices, right? And it says you go over here to A1 and you over here go over to D3, right? It's like it's positioning the stem cells where they need to go because it provides direction. So that's LL37 as well, right? So it's absolutely an amazing, like it's running around doing all of the things that are associated with what we think of as anti-aging: tissue repair, cellular repair, and then also the microbial side. So what do I think is aging? I think it is periodic moments where we're not producing enough LL37, and then that causes essentially damage that we're not able to catch up on later. And that comes from lack of sleep, dehydration, infections. You get an infection, and then all the LL37 is moving over there to fight the infection, and it's not replacing the aged cells during that time, right? And so you can see people, they get sick and they look like they've aged. Like people go like, "Oh man, you're not looking good. You look like you've aged 10 years," right? Like you've heard that before, right? And then that's like, I mean, not about your personal condition, but I mean, you've heard other people say it before, right? And so I really think it has a lot to do with that. Now, is that the silver bullet that cures everything and that's the end of aging if you produce enough LL37? No, I don't think so. Because I think if you produce the optimal amount of LL37 right now, it's not going to reverse your age. It's gonna slow your aging, but it's not going to reverse your age. And so how do you reverse the age, right? Well, that's a different question altogether. So it's a different question from what is aging versus how do you reverse age, which I do believe it's been done before. And that's been done in mouse heterochronic parabiosis.
So I have a question about the 37 peptide. If a person starts taking this peptide, what are some of the effects that they can expect to experience and feel and see once they start taking the peptide?
Well, I did it, so I can tell you. The peptide, if you get too much of it, so like if you overdose on vitamin D3, right? So I was during COVID, I got super paranoid and I was taking massive doses of vitamin D3, K2, right? And so I didn't realize that I was taking too much. I just thought, well, you can't have too much to have a good thing, right? And so I was taking these big doses and I started to feel sick. I started to feel inflamed. I started to get sort of like red patches on my skin and stuff. And I'm like, man, maybe I've got COVID. I need to take more vitamin D, right? And so I started like really feeling sick. And then I don't have the, everybody's telling me about what the symptoms of COVID are. I don't feel like it's those, but I do feel like I'm sick. So then I started researching, and I just like, what is it possible that I'm overdosing on D3? And I looked it up. I was actually producing too much LL37. And so because this peptide was being overproduced all throughout my body, it was essentially like trying to attack things that shouldn't have been attacked. So one of the ways that pathogens attack your body is they mimic apoptotic blebs. So an apoptotic bleb is essentially like if you leave there's these old movies like Coming to America where like
My sister's favorite movie. It's funny.
it's one of I know every line in this movie, right? And so they're walking through, is it Brooklyn or Queens? They're in Queens, right? And so they're walking through Queens, and there's a car behind them, right? Somebody parks a car behind them. I think it might be their car. They bought a car or something. Remember what happens to their car? Like it disappears part by part. The hubcaps come off, the wheels come off. Like every time they go by the car, there's less of the car there,
Hmm.
right? And they're like, "What's happening to the car? It's like disappearing," right? So that's what apoptosis is the body comes in and starts taking apart a cell. So the cell says, I'm aged, and it puts a marker on it. That marker happens to be called phosphatidylserine, right? Which is essentially the body's eat me signal. And so all your aged cells in your body have that marker. So LL37 comes along and targets that marker and essentially starts like chopping the car up, right? It's like a chop shop, right? It's chopping the car up. It's chopping the cell up, right? And so it takes it apart and it puts it into little blebs, they're called, little tiny pieces, basically. And then it offers those to all the surrounding cells as basically a recycle reuse. And so it gets offered to all the local cells. The local cells pull it in and basically eats it and recycles those proteins for their own good, right? So that's the orderly process of apoptosis. And then a stem cell comes into the gap where that cell was, a fully formed brand new cell goes in where that was. That's what's happening like a trillion times inside of your body right now. It's going all over the place. Everywhere in your body is going through that process all the time, right? Very orderly process. So what pathogens do is they mimic the apoptotic blebs and they mark themselves with phosphatidylserine. And the same mechanism that your body uses to absorb the apoptotic blebs is the mechanism that the pathogens are mimicking. It's like a Trojan horse attack, right? Where it says, look, I've got phosphatidylserine. Let me unlock the cell recycling bay, and it comes in, and now you're infected with this pathogen, right? And so if you have too much LL37, you won't be able to get the apoptotic blebs for recycling because the LL37 will be targeting the apoptotic blebs and taking them all apart, right? It'll be hitting the phosphatidylserine. Of course, it'll also be taking apart all of the pathogens too. It'll be ripping all the pathogens to pieces, right? But if you then lower the LL37, well, then you can get infected and you can also recycle. And so your body is constantly managing the LL37 levels depending on in the local area, right? Depending on what that local area needs at any given time. So it's really tricky. So this is what I said is, LL37 is not the end all be all of forever young, but making sure that you're getting enough nutrients and exercise and vitamin D, sunlight naturally, that will definitely slow down the aging process. But you said like if I take a peptide, right? One of the problems with taking LL37 is the body knows that it needs this very stable balance of it. And if you take it like as a shot, then the body gets rid of it super quick, like within minutes. I don't know how much pay for LL37, but it's not cheap, right? And you inject it, and within minutes it's gone. So it's just really wasted money to take it externally, right? So exogenously is what that's called. So endogenous production of LL37 is key. I'm a co-inventor on a patent of it, which is basically just getting good nutrition and sunlight. And there's a bunch of supplements that work all together that produce more of it. But I think LL37 is absolutely key. And because it disappears so quickly, what I'm working on, what the company Maxwell Biosciences is developing is a synthetic version of it that is much more robust and sticks around longer. It doesn't degrade within minutes. It takes like 6 hours for it to degrade. And what we've shown is it's effective against every kind of microbe, every kind of pathogenic microbe, and basically anything that can infect you, it's effective against. And it's completely selective. It doesn't attack any healthy human cells, and it also keeps the commensal microbiome safe as well. So we just launched actually this morning a press release around entering into the cosmetics industry with this new compound, because cosmetics, makeup and eyeliner and all that, it gets infected because you put it on your face and then you put it back into the bin, right? And then you put it on your face again. So you're taking the pathogens and the good microbiome off your skin and putting it into what turns into like a petri dish. It's a petri dish with makeup in it. And then you end up getting infected from it. And so the cosmetics industry has to put antiseptics in there. And right now, those antiseptics are pretty toxic for your skin. It's not good for the microbiome of your skin. And so they're looking for basically what I just described, right? They're looking for something that doesn't kill the good microbiome, doesn't kill the human cells, but kills the pathogens. And so that's what we've got. So we're entering into the big business of the cosmetics world, livestock, surface sprays and coatings like you use in your kitchen or your bathroom or whatever. So it's not just taking it to the FDA, which we're also doing. We've got several different molecules that mimic LL37, and it's going to be everywhere pretty soon. You're literally going to be covered in it if you wear makeup, and then your kitchen and your sink and everything is going to be covered in it as well. Pretty soon, coatings as well, like buttons on the elevator will be coated in it. So it's going to be pretty much everywhere. We're going to make it extremely inexpensively.
It's great to hear. And I'm curious about with L37 if it helps. I think you kind of talked about this a bit already, but if it helps prevent people from getting sick, because before I did what I do now, I was a teacher. I was a teacher for 7 years. And, people who work in the
I can
teaching
see that
field,
about you, actually.
thanks.
Yeah,
People who
you're
work in
very
the
patient.
Thank you. I appreciate that. I actually was not patient at all before I started teaching, but I learned very quickly within a year or two to be patient. I've learned a lot from the kids, actually. They taught me probably as much as I taught them. But when you're teaching, you tend to get sick a lot, like you would if you worked in a hospital. And some of my friends, they're still teachers, they're still in the profession, they're still getting sick, 2, 3, 4 times a year. If they were to take 37 peptide, would that help protect them against some of these infections?
So it's not good to take LL37 as an exogenous, like an external medicine, right? Because it can't survive the stomach acid for one. The only way that you'd be able to take it would be like a subcutaneous injection, which means like underneath the skin, where you kind of pinch your belly fat and put a little shot in there. And I take peptides that way. There's many different types of peptides that I take, and we could talk about later. But with LL37, the best way that you can essentially take it, right, get more of it inside of your body, is to convince the cells in all the areas of your body to produce more of it. And it can prevent getting sick. And so it's produced in very high amounts in any of the surfaces of the body that contact the outside air, for good reason, right? Because the outside air can infect you. It can have pathogens in it, right? Airborne, like, a little kid comes up to you and sneezes right in your face, and you're like, oh my God, like, I hope, I don't get sick, right? Well, because all this mucus from the kid just hit you. Now, what is the defense against mucus? It's actually your own mucus. So the tears, your tears, yeah, you could be crying if you just got sneezed on by a kid, right? Like, I don't want to get sick. But also, like, just the tear ducts produce a lot of LL37, the mucus in the nose, the earwax, your saliva has a lot of LL37 on it. So like if you have a dog and you get a skinned knee, like my example before, the first thing the dog will do is come up and lick your skinned knee. It's not because the dog likes the taste of a skinned knee. It's because the hundreds of millions of years of evolution tells dogs to lick each other on the wound, because the LL37, or the dog's version of it, the canine cathelicidin peptide, is in the saliva in huge amounts. And so it's one of the ways that you can measure how much LL37 you're producing, is actually just to measure the saliva. So in a lot of human studies, and I've probably read just about every single one of them, where they're testing to see how much LL37, they test the saliva, and they also test the blood serum levels of LL37. So if you want advice for your fellow or former teacher friends, the best thing they could do is take plenty of vitamin D with K. So K2 activates the vitamin D, and take it with like coconut oil all at the same time. So sometimes if you get vitamin D, it doesn't come like in a oil container. It needs to come in an oil container. And then take it with magnesium, calcium, and with coconut oil all together. So I actually mix it in coconut oil, and I'll put the supplements in the coconut oil in a spoon, and I take the coconut oil with all of it, because the fat in the coconut oil allows you to absorb all of it all together at the same time. The magnesium is really important too. So is folate. I can tell you a little bit about folate too. Methylated folate is really important. Folic acid is not folate. Have you already gone over this before in your podcast?
Nope,
So
not yet.
folic acid is a synthetic way of producing a molecule that looks very similar to folate. So your body produces folate, and you need it. It's in all kinds of different foods and things too. You absolutely need it. You don't have folate, you will die. The problem with folic acid, which is a synthetic, comes out of a lab only, nothing in nature makes folic acid. It is produced in a totally synthetic fashion that mimics the structure of folate, and your gastrointestinal system thinks that it's folate. Your gastrointestinal basically filter of like, is this a good thing for me to absorb as a nutrient or not? It thinks it's folate, and so it absorbs it. And so now it's in your bloodstream, right? So it goes through your gastrointestinal wall into your bloodstream, and it's going through the bloodstream. And so the initial connectors on your cells see the folic acid come along, and they go, oh, it looks like folate. And so they take it and they try to pull it into a cell, right? And now inside the cell, where the little engineers inside of the cell actually have to use it, they say, this is not folate. This is folic acid, right? And so in about 47% of the population, basically the engineers go on strike. They're like, just like, I cannot deal with this. Nobody's paying me to deal with this. I'm going home. Those people get super sick. 47% of the population will get very sick with folic acid. And yet it isn't everything. It's in American bread. It's on all kinds of things. So like the bread that says it's fortified flour, that is folic acid. And they have been putting folic acid in American flour and bread for like 75 years, since World War II. So somebody way back in world, they're dead now, right? Nobody's alive that did that. And so no one has corrected it. It's like just this leftover ancient mistake that somebody made. And people are like, why do you put folic acid in the bread? Oh, we've always done it that way. It's crazy. And that's one of the reasons why so many people in America think that they're gluten intolerant. It's not the gluten, it's the folic acid.
Wow, that's interesting. I never knew that. So, when we talked about LL37, you said it is the peptide that slows aging, but you said there's also a way to reverse aging. What's a way to reverse aging?
Reversing aging is much more complex. I would say it's definitely what you're saying about taking a peptide. You would need to take peptides. Like you would need to have, it's one thing to change the oil on your car regularly and put the right kind of gasoline in it and all of that. That's sort of like keeping your LL37 levels good, right? If you don't change your oil, your car is definitely going to die an early death, right? No doubt, right? That's keeping LL37 at optimal levels, right? Taking your car to the mechanic, that's like stem cells, exosomes, hyperbaric oxygen, um, uh, like infrared light, saunas. There's injection of peptides, subcutaneous injection of peptides, IV drips of various different substances. So there's a whole biohacker community around this. Basically, that stuff, right? That is how you reverse aging. And there's a lot of science around that. There's also microbiome manipulation that you can do. So, like fecal microbiota transplant. Have you heard of this before?
Yeah.
So fecal microbiota transplant is, fecal means poop, right? So that means the microbiota of the large intestine. And so they can measure, there's tests that they can do, and they can measure your microbiome and they can see if it's optimal for health span. And there's many different ways that they can look at it now. It's called shotgun analysis. And so they'll do this broad analysis of everything that's in all of the pathogens, all of the good stuff that's in your gut. And if you have too many pathogens or you have an imbalance of the good stuff, it means that you're not going to be getting what you need in order for long-term health span and even for optimal energy and all kinds of things like that. This is big in sports performance now, is optimizing the microbiome, because a lot of the energy and also absorbing nutrients and stuff, right, comes from the microbiome. And so one of the ways to do that is basically you have somebody who has kind of a perfect microbiome. And there's people that are just sort of, that's what they do for a living. Like my job is to have a perfect microbiome. Like that's their job, right? And they are now fecal microbiota transplant donors. And these people are treated like kings and queens. And so they just are donating their microbiome. And that's literally, it's pretty easy for them. It's It's really just comes from poop, right? So they poop, they give a poop sample. There's a process that the poop is cleaned basically, and then they take the microbiome out of that. And then you go to a clinic and you can get a fecal microbiota transplant. And this has saved people's lives. It has cured diseases. It has caused all kinds of wonderful things to happen. There are autistic kids that get fecal microbiota transplant and they're not autistic anymore. So there's something in the microbiome that changes that. So it's not very well understood because obviously poop microbiota is not the sexiest thing in the world for people to work on. Not very many people want to work on that. And so it's not super interesting. Even at the big, the aging conferences that I go to, most people don't want to talk about it. Most people want to talk about the really sexy stuff right now is like cellular reprogramming and things like that, where it's like genetics or CRISPR or things like that. That's where people go like, wow, I want to go, find out how to replace the DNA in my cells. I'm sure that's going to make me better, right? But if you do that, right, that would be kind of the most expensive thing you could possibly do. CRISPR therapy would be, maybe $1 million or something that you could do, and you might not even see any difference if you have a bad microbiome, you're not producing enough LL37, and you're not doing peptides or stem cells or any of that stuff. It might not even do anything for you. So yeah, so reversing aging, I would say probably stem cells and exosomes and red light therapy, infrared therapy, and hyperbaric oxygen. Those are the things that I've seen have the biggest effect.
And you mentioned earlier on in the podcast that saunas also help improve people's lifespan. How do saunas help improve lifespan for people?
So heat shock proteins. So it's quite interesting. So shock proteins, LL37 is one of them, the peptide we've been talking about, right? And there's others. Heat shock proteins are another protein that is strangely named because they're also produced in a cold plunge when you go into extreme discomfort, essentially. They should be called discomfort proteins. So during exercise, super hot sauna, super cold water, like any of those scenarios where you're just going like, I don't like this, right? Basically that signal that I don't like this feeling is your cells are complaining. Your cells your tissues are literally complaining to your brain and saying, I'm under a lot of stress right now. I don't like it. I'm having to expend a lot of energy in order to just maintain cellular integrity, right? Like it is so cold right now that if I don't produce a lot of energy right now, I will freeze. Like I will crystallize. My cell will crystallize. You need to get out of here right away, right? That's what it feels like. Have you ever done a cold plunge?
No, I never would. I'm such a when it comes to the
Oh
cold.
man, it is discomfort. Like it is discomfort, right? You have to just meditate. Like I do every time my hands do this, and I'm just like, and I just barely make it through every single time. And I'm better in saunas, but it is very discomforting, right? And so what's happening in that process is anything that is not, especially if you really push it, if you really push yourself into the discomfort, what happens is the cells that are not optimal, the cells that are not forever young, the ones that are not strong, die. They die in that process, and so they go into an apoptosis process, right? And so because they're having to go into this apoptosis process, your body then starts producing heat shock proteins in order to get rid of those cells. Essentially, lots of cells start saying, I need to be replaced because I'm failing now because you just put me under so much pressure. Now I'm quitting, basically. And so then you have to have basically the security guards come in and say, oh, these people are quitting. I have to escort them out the door. And that's what the heat shock proteins do. LL37, and there's several others that I'm not, but essentially those go in and they're essentially poking those cells and blowing them up and blowing them into little apoptotic blebs. And then they're getting recycled and processed through the liver and recycled for the surrounding cells. And so those are old, weak cells. Those are old, weak cells that are being destroyed in that discomforting process. The problem with it is very not comfortable, right? So most people don't want to do it.
Yeah.
So one of the ways to slow down aging is to seek out discomfort. So people that have the discipline to seek out discomfort tend to be healthier, right? And the people that are seeking comfort and seeking pleasure, those people tend to age faster. Like look at a rock star, right? Like they tend to age really fast, right? They might be in their late 30s and they look like they're in their 70s, right? They have living fast is what we call it, right? They're not getting sleep, they're drinking lots of alcohol, they're doing all these bad things versus somebody who's got the discipline to seek out discomfort, maybe is fasting. Meditation can sometimes be discomforting, right? Looking inside, all of those things are really good for extending health span.
So there's a lot of science going on right now in the field of longevity, but have there been any recorded histories about the science of longevity already?
Yeah, that's. I mean, I could just go on that. So the ancient Vedas, which are the ancient kind of historical documents of India, they talk a lot about aging and about how to extend health span with a type of health science called Ayurveda. So Ayurveda is the scripture of health, basically, or the book of health, or the word of health. Ayur means health, and Veda is scripture or word or book or whatever how you interpret it. So Ayurvedic medicine is pretty popular all over the world, especially like in the Middle East and especially in India. Basically, everybody does Ayurvedic medicine in India. They also do Western medicine as well, but it's becoming much more popular in the United States, especially in like California, basically where people do a lot of yoga. Anyone who does a lot of yoga, they generally hear about Ayurvedic medicine. And it's this ancient medicine that's thousands of years old. And it uses mostly like plant medicines and things like that. So that has been the study of health span. It's not the study of disease, it's the study of health. And so those are essentially thousands of years of human trials that you can, even the FDA recognizes Ayurvedic medicine as generally recognized as safe. You don't have to go through human trials in order to make claims about things that are in Ayurvedic medicine, and that's a rare exception for the FDA. There are also Western and African traditions of um, basically it's like what do the wise old women of those cultures and the wise old men of those cultures, like the shaman or the medicine people of those cultures, what do they say to eat and how to live, right? And so listening to that is really important. And one of the things I tell people, just for general health purposes, is you either eat your culture or your culture eats you. So, so we like to say, like, you'll get on Instagram or something, and you'll see a video, and it's recommending like some diet or something that everybody should be on. Well, in actuality, the diet that you should be on is the diet that you should be on, right? You should be, because we have different genetics, we have different blood types, we have everything is different about us because your ancestors evolved in a completely different environment than mine did, right? And so the lessons of maybe millions of generations, like let's go back like a billion years, right? Go back a billion years. We're probably cousins from that, right? We're probably cousins from a billion years ago. But when you come forward and you go into like the millions of years, that's when you see human populations starting to diverge all over the world, and they're adapting to different environments, right? And so certain cultures then adapted over at least hundreds of thousands of years to eat a certain type of food and to be in a certain type of environment, right? And so that is your culture, right? And that's where you go to your grandmother, and your grandmother cooks a certain type of food, and you just feel better after you eat that type of food, right? And we call it comfort food, right? Well, it's because your body's going like, yeah, this is exactly what I need, right? And it's different for everybody. Everybody has their own culture, right? So you also have a culture of bacteria inside your body, and so we do cultures of bacteria, right? So there's a little bit of a play on words with the two cultures, right? And so that's where you eat your culture, you eat what your grandma said to eat, right? Yes, ma'am, grandma, right? Or the culture of your bacteria inside of your body will actually rebel and start eating you, right? You'll self-infect. Your bacteria will actually get out of hand, and you'll have belly problems. You'll have all kinds of problems because you're not eating the right food, even though you're eating what appears to be healthy, what Instagram is telling you is healthy or whatever, right? So you got to eat your culture, or your culture will eat you. You can't just eat whatever everyone says is healthy. You got to figure out what's right for you. And the best way to study that, the best way to really dig into it, is to dig into your family tree and find out where people came from and what did they eat in those areas, and what do intelligent people in that area eat today, and find out. It's I find that sort of the it's almost like sort of health anthropology, right? Where you're sort of going back in time and finding those things out. I find it incredibly interesting.
Yeah, that was actually something I did maybe 5 or 6 years ago. I did the ancestry.com test just to figure out what my genealogy was because no one in my family really knew. And I found out, I'm like, okay, this is interesting. And that's all I've really done with it so far. I haven't done much else. So it would be interesting to go and see what the people of that area actually ate back then and what they're eating today. So I think I'll check that out. Thanks for the
Hmm.
recommendation.
Yeah, that's cool. Yeah, looking up the like the traditional medicines from that area too. That's really interesting too. I'm in biotechnology, and that's one of the ways that Maxwell Biosciences innovates is by looking at ancient medicines like Ayurveda, but also many other cultures like neem in Africa. Have you ever heard of this before? Neem, the neem plant, highly anti-inflammatory. Also helps with pain and lots of other things.
How do you
I
spell it?
visited Neem. You can get neem oil, you can get all kinds of things, but it's like I found that to be super interesting. I studied neem for a while, and its anti-inflammatory properties, but like it's got molecules in it, right? It's a plant that has molecules in it. Any of those molecules could become a pharmaceutical. So there's an infinite number of potential pharmaceuticals out there where if somebody wants to start a startup or something, that they could just do it. And then there's also the nutraceutical path, and then also just the natural plant medicine side of things, where you don't have to be in biotechnology. Like you could literally just go get some neem, make some neem oil, name it Harper's neem oil, and you've got a product. So
Nice. That's also another thing that I want to talk to you about is inflammation. A lot of the people that I've had on the show have said that inflammation is a key aspect of aging. It's the main thing that accelerates it. Have you found the same thing to be true, and what can be done to counteract inflammation?
yeah. So inflammation is basically your body is saying there's something wrong. And if you have systemic inflammation, it feels like depression or anxiety. So the depression means your body is saying there's something wrong, lay down and go to sleep. And then anxiety means there's something wrong, look around for it. Like try to find where is it, right? Be hyper alert. And so usually today, in today's day and age, anxiety is not going to help you at all. It's just a self-defeating thing. It's not going to help you at all, because there isn't like, you're not going to look down and see that there's a snake with its teeth embedded in you or something, right? Like that's not going to be what happens. It's probably you got some folic acid in your bread, or like you got something invisible. You're not going to be able to see it. So generally, not always, but generally, fighting inflammation or reducing inflammation is best for you. And then you just take it easy and see what you can do around it. So for me, and I get inflamed sometimes. The reason I got into biotechnology is I have a pretty delicate biology. My whole family does. I'm just sensitive to a lot of different things. Spiritually, energetically, I get overwhelmed by too much noise. But then also with food, right? I'm very sensitive to different types of food, which is why I ate bread for so long, and I felt so bad after bread for so long until I found out about folic acid, and I'm like, oh my god, they've been poisoning me this whole time. Because I also did 23andMe, and I saw I'm homozygous, which means I have both copies of a gene, which makes it difficult for me to methylate a food. And so I'm not getting enough folate anyway. You have to methylate folate. And then what did I do? I went and took folic acid as a supplement because I saw the 23andMe data. I'm like, oh, I need more folate. So I took folic acid and I got so sick. Oh my God, it just made me the sickest ever. Depression, anxiety, inflammation, like really, really messed me up. That's how I found out about all this, what I told you about folic acid. So I had my share of inflammation. The thing that helps me the most is really easy to do. It's literally just fasting, like just fasting and making sure that I'm not getting anything, no poisons. So I'm allowing my liver to just process out everything that's inside of me, and I'm drinking filtered water that doesn't have chlorine in it. So no chlorine, no fluoride, like as close to just natural pure water as I possibly can. And I'm just trying to flush. I'm just trying to flush the body, just flush everything out. Because usually what I find is that depression and anxiety are because of something I ate, almost always. I actually have a really high tolerance for stress, for pain. Like I can work out to the max every single day. I can deal with business stress, but I can't deal with toxic food. And so just fasting, flushing the body, and the other way to flush the body is with breath. So really deep inhalation, holding it for 5 seconds, really fully expressing all the carbon dioxide. And when you're expressing that carbon dioxide, there's more than carbon dioxide that's coming out. It's a detoxing process. So it's not just carbon dioxide that's the toxin that you're getting rid of. There's all kinds of things in that breath, out breath, especially when you go deep, hold, and then release. That's a way to detox. And so you can actually take a lot of the strain off of your liver by doing that. Also, working out enough to get to start sweating. So that also you end up filtering your blood that way by sweating. So sweating, breathing exercise, deep breathing exercises, and fasting and flushing are the ways to get rid of depression and anxiety, inflammation. The problem is you can only fast for so long, right? So you need to make sure that what you're eating and what you're drinking are really clean things. And the way to go about that would be an elimination diet. So where you just say, I'm gonna only eat rice, right? And or I'm only gonna eat potatoes or something. And if you feel sick from potatoes, well then maybe it's the potatoes that are making you sick, or maybe it's the rice that's making you sick. So the way I fixed it for myself is I went 100% carnivore, which is very difficult to do. I don't know if you've done that before. It's very, very hard to do. When your bacteria and your metabolism likes cookies, likes chocolate, like you don't get any
I love
chocolate, right? You don't get
cookies.
any of
My
that.
favorite treat.
Yeah, people are like, I love meat. I would love to be a carnivore. I'm like, oh man, you have no idea. It is hard. It is really, really hard. And so I got really sick for a while, and I just said, okay, I've tried many different things. I've tried, just potatoes. I've tried just rice. Now I'm going to just try beef. So I went to just a 100% hamburger diet, not even just steak, like only hamburger because it has connective tissue in it. Steak doesn't have a lot of connective tissue, and so I have a little bit of connective tissue issue that goes along with the methylation issue. And so I just started eating hamburger, and man, I felt great. All my sicknesses just went away. All my weaknesses went away. I felt so good. I got super ripped. I got so much energy. I started working out every day. And so I'm mostly carnivore now. I eat, I have some vegetables and stuff. I almost never have any sugar. I don't drink alcohol. And so I live a really, really healthy life from a lifestyle perspective. So, but that's just for me, that carnivore lifestyle. And you can kind of tell from your body what you need too. So like I have pointy teeth, like a wolf, right? Like a carnivore. Some people have really flat teeth, right? Some people have really flat teeth, which is for grinding vegetables, right? And so your body will kind of tell you what it is you're supposed to eat, right? So that's why I went carnivore, is I could not figure out what was wrong with me. And I'm like, I have really pointy teeth. Maybe I'm not eating enough meat, right?
Another thing that I want to talk to you about is your compound called Claromer. Can you tell us what it is?
Yeah, so Claromers are a family of compounds, and they're called compounds because we're taking some of them to the FDA, and it's only after the FDA approves them that they're called a drug. but we're developing them to be drugs. Uh, uh, we're developing them to tackle just about any kind of bacteria and fungus. That's our first target. What the military is showing, what our labs, our lab partners, many universities, government of India, government of Australia, what they're all showing is that these compounds are universally applicable against pathogenic bacteria and fungi, which is really exciting because antibiotics are dying. So antibiotics are not effective the way they used to be, and people are starting to die. And a pretty serious number of people are dying just from antibiotic resistance. So bacteria that used to be treatable with antibiotics are no longer treatable by antibiotics. And the luck of the draw, some people are, getting the short end of the stick there. And then they go in and the doctor says, there's nothing we can do. This bacteria is totally resistant to anything that we've got. And so, we're going to keep you hydrated and hopefully you'll, survive. So a lot of those people don't survive. So we're making a compound, developing a drug that could potentially solve that problem. There's a lot of unmet medical needs within that field, many billions of dollars worth of unmet medical needs. So there's a lot of money to be made there, and there's a lot of lives to be saved. Our goal is to make the medicine as affordable as possible. And so the mission of the company is to create health for the world safely and affordably.
How do you envision this medicine being taken? Is it something that'll be taken when you get sick or something that'll be taken consistently to prevent sickness?
It's to be taken when you get sick, or potentially when somebody in your family is sick and you feel like you might get it. The FDA would have to rule on that, but that could be potentially something that the medicine could be taken for as well.
And do you see it being able to help with chronic conditions as well?
Absolutely. A lot of chronic conditions, especially autoimmune conditions, are due to underlying infections. There's a lot of studies on that. And so taking care of the semi-permanent chronic infections that are inside of all of us, I can do nothing but help. So there's a lot of potential there for chronic diseases.
One thing that I saw on your website when I researched Claromer's is chronic sinusitis. Can you tell us about what that is and why so many people in the US have it?
Yeah. So chronic sinusitis is antibiotic resistant by definition. So sinusitis is like an irritation of the lining of the sinuses. We've all had it, right? It can be allergic. It can be, a bacterial, viral, fungal infection, any of those things. And so acute sinusitis is when you've got it and, like a week later, it's gone. Chronic sinusitis, it doesn't go away. It just stays there. I used to have it. I know a lot of people that have had it where they're constantly battling with sinus pain. They're getting, migraines from it. They're getting eye pressure and pain from it. Sometimes they're like some cognitive impairment. So people call it brain fog or memory loss, or like you're just not at your best. You're having a really bad day because you've got this problem, right? And most people get it only acutely, where they only have it for a short amount of time. There's an unfortunately high number of people that basically just have it all the time. So their best is when it's not so bad, right? And there's some days where they can barely talk, they can barely think. They're in a grouchy mood because they're basically just like this, right? They're just like, oh, my face, my nose, my sinuses, they're just having a really hard time. And so they go to the doctor for that. And of course, they've already been to the doctor many, many times for it because they've had it for a long time and they've had every kind of antibiotic. And maybe they take the antibiotic and maybe they skip a couple of doses or something. And so now the bacteria that they've been fighting is now resistant to it. And so they go back into the doctor and they're like, I've got it again. And he gives them the same antibiotic. It doesn't work at all. And so then they go back in, they try another antibiotic. And for some whatever reason, there's this group of people that after a while, they've tried all the antibiotics and it doesn't work. That's chronic sinusitis. So for those people, they're just in a world of hurt. Their lives are pain for a long, long time. And the only solution right now, there's basically two things the doctor can do. They can prescribe anti-inflammatories, and painkillers, right? And you can get addicted to painkillers, and the anti-inflammatories suppress the immune system, which actually accelerates the infection inside, right? Which is not good for you at all. But it sometimes it's just the only thing that you can do because it just hurts so bad. The other option is a surgery. It's called debridement surgery, which is a horror show. It's literally the scraping. They scrape out the inside of the sinuses. It's brutal and about incredibly risky surgery, very painful surgery, and about 50% of the time it doesn't work at all. So just the infection comes right back. And it gets risky because you've got an infection in this area, right? And then they're scraping and cutting in there, and it can get into the bloodstream. And so it's not a low risk thing. That's why they don't do it for everybody. And it's a little scary for the patient too. So those, obviously none of those options are good options. And so it's an interesting area for a company like ours to come in and try to solve that. That's called an unmet medical need, where it's just not a good option. None of the options are good options. So a nasal spray with Claromers in it is what we're developing for right now. We've already had interactions with the FDA, and those have been very positive for us. So we're continuing to interact with the FDA, preparing for human trials.
Excellent. Are there other ways you're developing the compound too? Because you said, you have the nasal spray. Are there other methods of injecting or taking it in the pill form or
Yeah,
anything else?
we're actually working with the military and with some other labs on formulating it as a pill for infections of the gastrointestinal system, right? Like we've all had diarrhea. So I wasn't allowed to say that word as a kid unless I actually had it, because I used it as like a curse word, right? Like diarrhea brains for my brother or something. But so every time I say it, I'm like, oh, my mom's going to hit me. But when you've got that, right, when you've got the D word, you definitely want to get rid of it as quickly as possible. It is not fun, right? And so having a pill that took care of that right away and didn't disrupt the microbiome, right now what happens is you essentially have to go to the doctor and get antibiotics if you've got a really bad case of a gastrointestinal infection. And sometimes that works, sometimes it doesn't, but every single time it destroys that commensal microbiome. And so Claromers are very selective for to kill only the pathogens and not the commensal microbiome. We had non-human primate studies that were very successful and showed that we were very selective for the microbiome. We've also studied in multiple other types of microbiomes, and we show that we preserve it really well. So I'm really excited about that. So I travel a lot, and I eat a lot of different foods in a lot of different countries, and sometimes I get infected from it. So it'd be really great to have something that doesn't affect my commensal microbiome when I'm trying to get rid of the D word. I'm really excited about that. And then also excited about potentially treating brain fungal infections with the same nasal spray. So right now, none of the antifungal drugs that are out there are safe for the brain. They happen to be the same compounds that are used in chemotherapy. So imagine chemotherapy in your brain. That would be taking an antifungal for the brain. It's just not possible. It would destroy your brain. It would kill you. So if you get a brain fungal infection, you're just toast. Like there's nothing anyone can do for you. And that is a completely unmet medical need. And it's just absolutely lethal. So I'd love to get in there and help with patients like that have no hope. And then soldiers, who are coming back from injured from battle, a lot of times they get infections so bad that they have to have their limbs amputated because of an explosion or something, and the dirt and everything, the grime that was in the explosion, it gets pushed into the tissues of the limb, and so there's pathogens, there's like microbiota, right? There's bad bugs in there, and it's pushed up into the meat of and there you can't clean it. You can't clean that wound, right? And they have the worst time of it. They just really have a horror. I don't want to go into the detail of it, but basically it's multiple amputations, and there's only a few of them. There's not very many of them that get it that bad. There's like 20, I think, in the United States right now. But man, I would love to do like some kind of fast track program for them, because the horror that they're going through, like multiple amputations, same limb, just chopping, chopping, chopping. And so it's just not it's most of them die after being chopped multiple times. There's no money in that for us. I mean, it would only be our expense, and I would love to take care of that. It's very choosing which thing to go after at any given time, who's going to pay for it, how we're going to develop the drug for it. How do we, there's all of these safety precautions and procedures. It seems like everything is super bureaucratic despite the emergency of saving somebody's life, right? So difficult to develop a drug, but our heart is in it. And I feel for those people that are suffering. I would love to help them.
So, when we started talking about Claromer's, you told me that there are several stakeholders in the success of the compound, such as different agencies and governments. And I was curious why there are so many stakeholders in the success of the compound and how it's been so successful in gaining funding, why people are so passionate about seeing this compound and its success.
So from the beginning, the Department of Energy, Department of Defense, many different universities, many different governments around the world have been deeply engaged with the development of the compound. And that started from the very beginning, back when Dr. Annalise Baron first invented it at Northwestern University in collaboration with the Department of Energy and NIH. And it's because there are so many concerned people when it comes to antibiotic resistance, because it's a no-brainer that it's a problem, right? So there was a scientist that was briefing the World Health Organization or some big organization, I can't remember what it was, and they said, if antibiotic resistance is not solved by 2050, it will be $100 trillion economic impact. 100 trillion, not a 100 billion, right? And when I saw that number, I was like, that can't be right. And so then I went and researched the number, and I was like, he's saying like catastrophic disease, basically, like everyone's going to die. Our civilization will come crashing down because if you get a bacterial infection, there'll be nothing to solve it. And so just basically every third person is going to be dying, which means you can't have a very good civilization during that time, right? So I'm like, okay, I get it. So that's, it's 2025. That's 25 years from now. We better have a cure by then. That's what he's saying. So it's a really big deal. I mean, they talk about it in every major world conference. Antibiotic resistance comes up. It's a big problem. It's on the same level as like asteroid impacts and nuclear war and all of that. It's a big problem. So it's not difficult to get governments to support us, especially with the data that we have, the non-human primate data, many different animals tested in, even human tissues that we've tested in, the microbiome. We show that it's anti-inflammatory, it's not toxic, and it also doesn't require refrigeration, which is a big deal in many countries, right? So India, Pakistan, Africa, Middle East, refrigeration, it costs a lot of money, and a lot of places just simply don't have the electrical connections in order to have a refrigerator. And so that means you have extreme health disparities in places where they don't have refrigeration. So it doesn't require refrigeration. So that's a big deal, right? So a lot of countries like India are very interested in our compounds because they don't require refrigeration. And so we're working with the government of India on some pretty big, really big programs, like maybe in the hundreds of millions to develop for some of the rare and neglected tropical diseases that they have over there.
So, when you're developing a new compound and trying to get FDA approval, it's a long, arduous process. What are some of the challenges that you face while developing your compound and getting funding? And what are some of the biggest challenges that you face today?
So I would say let's talk about like what are the key things that you need to look at for a potential drug, right? You need to say like, is there a market for it? Do people need it, right? Is there an unmet medical need, or is it just a medical need that's already met by something? There's something pretty good out there, right? So the best thing to go after is a completely unmet medical need, because the FDA gives you priority. There's people that are suffering that have no hope, and so it's best to go after those. Those are where you create the most value, right? So that would be the first thing: is where is the completely unmet medical need, and can you make something for that? Then can you make it? Is it something that can be feasibly produced in a factory, or like somehow can you source it somehow? Can you scale it up to large amounts that you would be able to serve it to people and supply it to people? And then the sort of classical things that everyone thinks about is it effective and is it safe, right? So safe and effective. those two things. So the safe and effective piece is it's a little bit easier to there's tests for those things, scientists and labs and stuff. You just have to have the money to find out if it's safe and effective. But I would say the key thing to focus on would be, is it a completely unmet medical need? And how many people need it? Those are kind of the key questions to answer. If it's a very few number of people, then generally it only makes sense if it's a really bad thing, right? Like, if there's 6 people in the world and they all have this undescribable tiny little itch on the tip of their nose, right? Like, okay, well, I mean, they're going to be okay. But if they're going blind, then that's a really big problem. You should probably look into that. So like looking at it from different angles and determining whether or not you should invest some time and energy into it is key. From that point forward, if you determine that it is something that is investable, it's something that you really should work on, then like as not, there will probably be other people that agree with you. And so those are investors. And so you just have to go find the people that are like-minded. The more, the higher the problem, pain, right? The more pain there is around this problem, the more likely that you're going to find people that understand that pain and are willing to invest in it. So that would be kind of the blocking and tackling of biotechnology and what you should develop versus what you shouldn't.
Awesome. I think that covers all the questions that we had today. Thank you so much for being here and for educating us on a lot of things I didn't know before, especially with peptides, Claromers, and health and longevity. It's been
Well,
a really
it
informative.
was a real pleasure. Big pleasure, and thank you so much for your patience. You're an excellent host, and I'm looking forward to more of your podcast.
Thanks, Scotch. That's all for today's episode of Forever Young, Region Leaders Share Anti-Aging Secrets. Thanks for joining us to uncover the keys to lasting vitality. If you're interested in learning more about Maxwell Biosciences, then visit maxwellbiosciences.com. That's MAXWELL biosciences.com. And don't miss our next episode. Subscribe now on Spotify, Apple Podcasts, or YouTube, and visit theharpermedia.com to explore how we can help your business grow. Stay vibrant, and we'll catch you next time.